The next task we're going to learn is to rationalize the denominator for square roots. Rationalizing the denominator means eliminating any radicals in the denominator, which is the bottom of any fraction. The following radicals are not considered reduced because there is a radical in the denominator. So here we have root 3 in the bottom, and here we have root 2y in the bottom. And here it might look like there's not a radical in the denominator. It just looks like there's a fraction inside, but really root 2/7 could be rewritten as root 2 over root 7, and there you go, you have a radical in the bottom, and that's a no-no. A really long time ago, so the mathematicians who were discovering irrational numbers decided that they weren't okay with having the radical on the bottom, and we still live by this very ancient rule of you can't have the radical on the bottom. So we just kind of have to deal with that. So we, as the simplifiers, need to eliminate the radicals out of the denominator. To do that, we have the following steps. Step 1. Reduce the fraction if possible. We're talking about inside radicals can reduce with other inside radicals. Outside coefficients can reduce with other outside, but if you have an inside and an outside, well, they can't reduce. For example, the first one says 2 over root 3. 2 is on the outside, root 3 is on the inside, so those can't reduce. But if you look at the last one here, root 24 over root 10, 24 and 10 are both under the radical, and there is a common factor there, so that one you might be able to reduce. Okay, so that's what I'm talking about by reduce the fraction if possible. Step 2, multiply both the numerator and the denominator by the radical in the denominator that you're trying to eliminate. This will provide you with a perfect square on the bottom, and it makes the denominator into something that is not a radical or a whole number. Then you want to simplify the denominator and then simplify the numerator. So let's go ahead and try this. 2 over the square root of 3 does not have any reducing. Step 1, you can't reduce because the 2 is on the outside, the 3 is on the inside. So we're going to go ahead to step 2. We're going to multiply the numerator and the denominator by the denominator, the radical in the denominator. So if you multiply the bottom by root 3, then you have to also multiply the top by root 3. So we're the ones that put that in there. Now, why was that helpful? Root 3 times root 3 in the bottom is square root of 9. And why is that helpful? Well, the square root of 9 is plain 3. So I multiply both the numerator and the denominator in step 2 by the denominator that we're trying to eliminate. Step 3 says reduce the denominator. Check, I've got that, and now I'm happy. Okay, notice the original one had a radical in the bottom, and that's a no-no. The answer is going to have a no radical in the bottom, and now that makes us happy. Okay, and then the last step is, once you've got the denominator done, go back and simplify the numerator. So 2 times root 3 is simply 2 root 3. You can only multiply outside things with outside things, and inside things with inside things. So, okay, let's keep going. So let's try the next problem. We have x over root 7. Now this is not rationalized because we have a radical in the bottom, and that's a no-no. So what I'm going to do is I'm going to multiply both the numerator and the denominator by some radical. The radical I choose is root 7. The reason I choose that is because when you're simplifying the bottom, root 7 times root 7 is root 49. And root 49 is a perfect square, which is plain 7. Not root 7, but plain 7, because the square root of 49 is plain 7. Then we have x times root 7 in the top, which does not reduce. Now, nothing else reduces here, because the only things that are on the outside are x and 7, and x and 7 can't reduce. Similarly, on the previous one, 2 and 3 can't reduce, so there's nothing you can do any further. Excellent. Let's go to the next one. Root 2 over root 5. So we have a root in the top and a root in the bottom, but the only one we care about is the root in the bottom. That is a no-no, and the reason it's a no-no is because you can't have a radical in the bottom. Are we allowed to have a radical in the top, the 2? Yeah, he's fine. We don't care about him. The one we care about is the bottom. So what can I do to eliminate that? Well, I'm going to come in and multiply by the square root of whatever the bottom square root is. in this case root 5. Let's make sure that that helped. So if I reduce the bottom, root 5 times root 5 is root 25, and root 25 is 5. Yay! Now I'm happy because I don't have a radical on the bottom anymore. Now that I've finished that, go back and multiply the top. Root 2 times root 5. Both of those are in the radical, so they can multiply up to root 10. And that's my final answer, root 10 over 5. Now, in case you're wondering, root 10 can be broken down to 2 and 5, but there's no pairs there, so they don't get to come out of the house. So that's as simple as you can get it. All right, the last one here. The last one we have 24 over 10. Now, because both 24 and 10 are inside the radical, and they both have a common factor of 2, the first thing I can do is reduce, just like a regular fraction. So what I'm going to do is I'm going to divide by 2. So I divide by 2 in the top and I get 12, divide by 2 in the bottom, I get 5. This right here is going to make my problem a whole lot more simple, so that when I multiply by the thing that I'm wanting to get rid of, root 5, it makes the rest of my problem much easier because I've reduced. Alright, so that leaves me in the bottom, root 25, and why is root 25 awesome? Because root times 25 is plane 5. So in the beginning, it had a radical. In the end, yay, we don't have a radical. So this is good news. Now I have to go back and finish the top. Root 12 times root 5 is root 60. But root 60 can be reduced. So that's, what, 5 times 12, 4 times 3, 2 times 2. I'm bringing everything else down so I don't forget anybody. The 2 gets to go on the outside. The 5 and the 3 goes on the inside. So anything on the inside gets to multiply and you get 15. Now, if perchance the 2 and the 5 could reduce, you would need to reduce that. Why? Because they're both on the outside. So anything on the outside can reduce with outside things. Anything on the inside can reduce with inside things. So just be aware of that one. Next, we're going to do some adding and subtracting of radicals. So when you add and subtract radicals, it's going to be very similar to adding and subtracting variables. For example, if you take 6x plus 3x, that gets you 9x. But if you take 6x plus 3y, notice your variables are different there, you can't add those. That's simply 6x plus 3y. You can't add them. Well, the first problem added together because they had like terms. The second problem didn't add together because they didn't have like terms. So notice that the coefficients add together. When they have like terms, they add together. But what happens to the variable for 6x plus 3x? Notice the 6 plus 3 made 9, but what happened to the x? The variable part stayed the same. Okay, similarly, when we add or subtract radicals, the radical parts have to be like radicals, or similar radicals, in order to be able to add or subtract them. So all I did here is I replaced x with root 5. So 6 root 5 plus 3 root 5. Are the roots the same? Yes. Can I add the coefficients? Yes. To get 9 what's? Root 5s. Okay? So if you think of like 6 root 5 sitting in front of you, so think of like 6, I don't know, whatever root 5 looks like, so 6 of them. Then your pal comes along and gives you 3 more root 5s. What do you have? Well, you have 9. What do you have? Root 5s, 9 root 5s. When you're adding, you're just adding like terms there, okay? The radicals are going to stay the same, just like how the x's stay the same. But if I don't have like radicals, 6 root 5 plus 3 root 2. Notice the root 5 and the root 2 are not like radicals. You cannot add those, just like you couldn't add x and y. So, to summarize, the first problem added together because they had like radicals. The second problem didn't add together because they didn't have like radicals. And remember that when the coefficients add together, the radical parts stayed the same. So the radical 5 stayed radical 5, but the 3 plus 6 turned into 9. So my steps here are simplify the radicals, rationalize the denominators if I need to, but then add the coefficients of all like or similar radicals. Okay, so 9 root 3 minus 4 root 3. Root 3 can't reduce at all, so I can't do step 1. Step 2, there isn't any denominators to rationalize, so step 3, just add like radicals. So 9 root 3 minus 4 root 3 is going to be 5 root 3's. The root 3's are the same, so they stay the same in the answer, and then you just add or subtract the coefficients. It's as simple as that. So the next one, root 2, root 2, root 2 are all the same, so I'm going to add or subtract the coefficients. Now, don't forget that the third term didn't have a coefficient, so that's an invisible coefficient of 1, just like if you have a variable like x, then the coefficient is 1 if it doesn't mention it otherwise. So 4 root 2 plus 3 root 2 is 7 root 2. And 7 root 2 minus 1 more root 2 is 6 root 2. Very simple. Now, the next problem, root 27 and root 12 aren't like terms, are they? They're not the same number. But root 27 and 12, both of them can reduce. So let's see if I reduce them, maybe they'll have like radicals later. So I have 3 times 3 times 3 for 27, so the 3 comes out. The single 3 stays home. For 12, I've got 4 times 3 and 2 and 2 and 3. The 2 comes out. The 3 stays home. Once I've reduced those, now the root 3's are the same. So they're going to stay the same. I'm going to take the coefficients 3 minus 2 and get me 1 root 3. Now, you don't have to write the 1 in front. You're welcome just to write plain root 3. Either way is fine. I'm not going to take off points. Alright, same thing here. Now we do have a negative in front, so just don't forget about those negatives. So I have 4 times 10 for the first one, so the 2 comes out. So the negative comes down, 2 comes out, and 2 times 5 multiplies and stays on the inside. The next problem, the minus comes down. 90, we'll say 9 times 10, which is 3 times 3 times 2 times 5. The 3 comes out of the house. The 2 and the 5 stay inside the house. And whenever you have more than one thing in the inside, they multiply. So 2 times 5 is 10. Okay, one more time here. The minus is going to come down. Root 60, the square root of 160 is 16 times 10. 4 times 4 and 2 times 5. Alright, so here's a little trick. 4 times 4 can keep going to 2 and 2 and then 2 and 2 if you want. But if you ever see a pair and you're looking for pairs, even if they're not prime, if they're a pair and you can circle them, you don't have to keep going. You can just circle that and take it out if you want. Now, if you didn't do that, if you broke it up into 4 and 4 and 2 and 5 and 2 and 2 and 2 and 2 and 2 and 5, you'll still get 2 times 2 on the outside, which is 4, and 2 times 5 on the inside, which is 10. So you'd still get it. I'm just trying to save you a little bit of time. So if you can understand that shortcut, please use it. Now, are my radicals all the same? I have root 10, root 10, root 10. I sure do. So my answer is going to have something root 10 in it. So I'm going to add the coefficients, in this case negative 2 minus 3 is negative 5. Negative 5 minus 4 more is negative 9. Okay. And then our last problem of this type looks like we have a rationalizing the denominator. First, here we have 4 over root 3. I can't leave it like that, so what I'm going to do is I'm going to come off to my side of my work here, and I'm going to work on 4 over root 3 to make it rationalized, okay? I can't reduce any of the other radicals, but I sure can rationalize, so that's what I'm going to do. So I'm going to multiply the top and the bottom by root 3. which in the bottom gets me root 9. And why is that helpful? Because root 9 is plane 3. So we started off to have a radical on the bottom, and then we're going to end without a radical, and that makes us happy. In the top I have 4 root 3. Now the 4 is on the outside, the 3 is on the inside, so they don't get to multiply. So I can rewrite 4 over root 3 as 4 root 3 over 3 minus 7 root 3. Are radicals the same? Yes, they are. So now all I have to do is take 4/3 minus 7. Now, unfortunately, 4/3 and 7 don't have a common denominator because one's a fraction, one's a whole number. So I'm going to get a common denominator. My LCD looks like it's 3. So I'm going to multiply 3 to the numerator coefficient and the denominator. So that gets me on the red one 4 root 3 over 3, so that didn't really change. On the blue, I'm going to multiply 3 to the top and the bottom, which gets me 21 root 3 over 3. Okay, are the radicals the same? Yes. Are the denominators the same? Yes. So my denominator is 3, and my numerator, I have 4 root 3's minus 21 root 3's, and that's going to end up with negative 17 root 3's over 3. And that is my final answer.